let us start with the new subject called as engineering mechanics. The subject, which has got basically two parts, considered as the statics and dynamics part, and these two words are related to whether the object under consideration is under the action of the forces which are in equilibrium, so that the object remains in the state of equilibrium, or the object is moving and how that particular movement is taking place, whether the displacement of that particular object is with the constant speed, we say, or the velocity or acceleration, or it is changing with time. All these factors are to be considered. So basically, engineering mechanics, as we start studying it, this mechanics subject is divided into two parts. First is called as statics, which is one full section, and another is called as dynamics. Statics will basically deal with non-moving objects, whereas in dynamics there will be movement. In other words, we will be saying that here the objects are in equilibrium, and this particular word equilibrium comes into picture in relation to the forces which are applied to the object. So the forces are actually in equilibrium, whereas for the movement to take place there must be some external unbalanced force. So there is going to be some external unbalanced force acting on the body, due to which there will be movement, which will result in velocity as well as the displacement. There could be acceleration, there could be impact and whatnot. So the mechanics subject, which is divided into two parts as we have seen it over here, the equilibrium, which is related to the forces, and the force again over here is nothing but the external force. Now here it is external unbalanced force, and if the forces get balanced, the problem will automatically shift to statics. If they are not unbalanced, that means they will be balanced, it will shift to the statics part. Now when we are going to learn this entire subject, there will be several topics which will come into this particular subject, engineering mechanics, and as you must have seen the syllabus, or quite a few might have appeared for the subject more than once. Remember that though the subject has been divided into chapters, like there is chapter of equilibrium or kinetics of particle or kinematics or impact, etc., etc. Remember that this entire subject is actually using some very fundamental principles which can be always applied, and if you have understood these principles very well, then probably teaching this particular subject is just a job of 1 or 2 hours, because once it is conceptually through, we don't have to actually deal with each and every problem. You will have to apply those concepts, those principles properly to each problem, and you will have to devise a method. Now there will be certain known forces or known entities which will come into picture, and certain unknown entities which will come into picture. Of course, from known to unknown will be the journey that we call it as solving the problem. So given some particular data, you will be using that data to find out some other answers, other unknown data items which are given in the problem. But in between, it does not mean that you will be directly getting, that is, there is a formula and in which you will be substituting everything so that you will get the result. It is going to be some procedure, and that procedure is not going to be the one which can be uniformly applied to all types of problems. Initially, as we start with the subject, yes, we can straight away say that there is a procedure and you will have to stick to that procedure. There are 1 or 2 topics where the procedure plays very important role, but in all other cases the subject is such that you will have to think at that time. It is not that the thinking is going to be on the same lines. You can be taking different paths, and then you will be reaching the dead end where you will find that you don't have sufficient number of equations by which the problem can be solved. Ultimately, you will have to come back and choose for another option, another choice, another method, another principle which is to be applied to solve the problem. And so, when we start with the basics related to engineering mechanics, we will be talking about some laws, and those are Newton's laws. Now, Newton's laws, when we consider, we have got the very first law of Newton, which says that the body will retain its state of equilibrium, that is zero movement, or will maintain its uniform velocity unless it is acted upon by the external unbalanced force. That was the very first law of Newton, which has to be understood thoroughly. Second law deals with rate of change of momentum is directly proportional to the external unbalanced force, and the movement will be in the direction of the external unbalanced force. If there are multiple forces acting on the body which are unbalanced, then of course you are required to find out the net force. That means these forces, they will have some cumulative effect, and that addition of forces is not going to be the arithmetic addition as such. Of course, here it is going to be the vector addition, because the direction of application of the force also plays important role. And then the third law of motion, which straight away says that action is equal to reaction. Once you understand these three laws, then there could be some other principles which will come into picture, like principle of conservation of energy. Conservation of energy. That means energy cannot be created nor it can be destroyed, but one form of energy can be converted to some other form. That is the law of conservation of energy. And you also have law of conservation of momentum. Of course, this you might have studied, or we will be studying it in the due course. Then there are certain other rules which will come into picture, like the laws of motion. And those are written in the mathematical form, like S is equal to ut plus half at square, or v square equal to u square plus twice as, or v is equal to u plus at. Some standard laws. So if we have understood these principles, probably we have nothing new to learn in this particular subject. We have just not even a single principle which is coming out to be a new principle, or something that we have not studied up till now, that is to be applied in this particular subject, engineering mechanics. One of the straightforward subject, rather a conceptual one. If the concepts are through, then the calculations also should be accurate, because if you make mistake in the calculations and if your final answers are not correct, then you will be given 0 marks. Because engineering is not the subject, is not the theme where you could be very strong only on the concepts and you are weak on the calculations. Suppose you are designing some bridge, your design procedure is accurate, but somewhere you have gone through the calculations in the wrong manner and you are not finding out the dimensions of those columns and beams correctly, then it is likely that that particular bridge might fail on one particular day, and it is going to be solely the responsibility of the corresponding design engineer. So the calculations also play very important role. One simple mistake, one digit mistake also will lead to trouble, and there could be several other persons who will be actually dealing with the object which you are going to design. Statics is actually the part where we will be dealing with the objects which are the real world objects, like buildings, dams, bridges, etc., where there is no movement of the object which we are designing. Whereas in dynamics we will be talking about the moving objects, and there could be several factors which are to be considered as where exactly the energy will be lost and what will be the speed and acceleration of that particular object and what we want to achieve. Let us start with the very first part in our syllabus, and we will have to understand the concept first of all as a force. Now what do we mean by a force? When we talk about a force, it will be fully defined by the magnitude and direction. So there will be magnitude associated with the force as well as direction. Normally it is shown, say, somewhat in this manner. Force F. Of course this length will be the magnitude of it. Now when this force acts on some body, say consider there is some block and some force is applied to it. Now what do you find that what is going to happen under the action of this force? First of all, we will say that this is unbalanced force. Why? Because there is nobody balancing it. Okay, fine. But first of all, I will have to assume that how this particular block is placed, because there has to be some support. Is it supported by some string from top? Is it connected to some string? Then even this string is not going to remain in this position unless it is supported by something. So the string is attached over here. And then what will you say? If the force is applied, probably this block is likely to change its position and might go to some other position where it is going to stop. Now why is it taking some other position and then reaching or going to be stationary at that position? Because we have seen it practically. You can actually have this particular block, instead of applying a force which is a pushing force, you can always have a pulling force. You can pull the block. For example, this duster, you just pull it and you can make it in the stationary position. Now the applied force is still there, because if I remove the force, it is going to attain its equilibrium position. Now what is this equilibrium position? Because the duster was hung from one end, I am pulling it, it remains in this position, and as I release it, it becomes vertical. Now why it is becoming vertical? Actually this support point and the center of gravity is the imaginary point through which the weight of that particular body will be acting. And if at a particular point the point is remaining stationary due to its own weight, say, then I will always say that there must be some force of the same amount acting in the upward direction, and then it will be in the state of equilibrium. So we consider the very first case where the object which is acted upon by two forces is in equilibrium. Then those two forces must have the same magnitude but opposite direction. Then and then only it will be in equilibrium. Very basic principle. A single body which has got no dimensions, we are not talking about a dimension, and over here the forces, the external force which could be the weight of the body, or there could be some other force which is acting, and if the body is not moving, then obviously there is going to be a reactive force, which is again Newton's law of third law, where action is equal to reaction, and overall it is in equilibrium because the net force acting on the body will be zero. Now how come net force is zero? Suppose this weight is something like 10 newtons, then you will say that this force is also 10 newtons. And if we say that there are two forces acting of magnitude 10 newtons acting on the body and body is not moving, that means this addition of the forces should turn out to be zero. And if you just consider the magnitude, that is what we call it as the arithmetic addition, then it will become 10 plus 10, 20. Whereas we say that if the body is going to maintain its position, then there will be zero force acting on it. And so this force entity that we are talking of, as we are talking about another thing which comes along with it called as direction, that direction will get associated with the force. And here if I am considering this as downward force and this as upward force, it is like our coordinate system that we use normally. any point on this particular plane will have the coordinates, and those coordinates might become positive or negative. Like over here, the coordinates could be 3, 3. Whereas here, they could be -2, -2. Here if I have some point, it is going to be -4, 1. Now here, as we are assigning the sign to it, we know that this particular coordinate is nothing but the distance from the axis. So the concept of distance remains the same. But why this particular sign? We are saying that one direction is positive, then the other direction will be negative. In a way, this particular negative sign indicates the direction. And it is opposite to the one which is assumed to be positive. Coming back to our problem, where we are saying that there is a force of 10 newtons acting on the body, which is weight of the body. And if I consider that downward force is to be considered as positive, then of course the upward force will turn out to be negative. Now this is a convention that you could be following. Somebody else might say that if the weight is acting downward, treat it as negative because it is downward, and upward treat it as positive. Which of these two conventions are correct? Of course both of them are correct. It will depend on person to person. Generally we will use this. Why? Because our coordinate system is like that. We will be always saying that upward is positive, towards right is positive. This is just a convention. And then the force will be associated with. So I will be saying that this force is 10 newtons and this force is -10 newtons, and the addition will turn out to be 0 and the body will be in equilibrium. So in your problem, if you get some answer as force is equal to -43.9 newtons, then first of all this is incomplete answer. This is incomplete answer because there is no mention of the angle or the direction. Now if I write that force is -43.9 newtons with theta is equal to 45 degrees, of course the answer is valid. But in reality, this answer can also be interpreted as it is 43.9 newtons, and if this was the direction of it plus 45 degrees, it will be the opposite direction, and ultimately you will have to show the direction like this. This is the direction and this is the angle that you are required to show, which will come out to be 225 degrees. It is not -45 degrees. That's why I am showing you this particular example. The angle doesn't turn out to be the negative one because the magnitude was negative. I am supposed to change the angle. It is going to be out of phase, opposite angle. You will have to straight away add 180 degrees so that the direction can be made the opposite one. Either subtract 180 degrees or add 180 degrees. Like for 225, if you add 180 degrees, it is going to become something like 405. But normally angle is between 0 to 360. So if it becomes 405, you will remove 360 out of it, it will become 45. So we say that the angle should be between 0 to 360 degrees. If it is greater than that, subtract it. Or if you are to change the direction of the force, then you should be adding 180 degrees or subtracting 180 degrees. Force should be generally written in the positive manner. But even if force turns out to be -1, it will be the direction which is to be considered as opposite, and the magnitude remains the same, 43.9. Any answer which is given in this form can be wrong. Any answer given in this form can be treated as the correct one because it is Fx, means the force along x direction. This could be a valid answer, but not just writing it as F equal to. That is going to be certainly invalid. So some factors are to be remembered. Here we have just taken a look at the object which is in equilibrium and is acted upon by two forces. Going back to our earlier example where I was applying some force and this was getting swung, and then we are of course having the weight of this block. You will say that initially if this force is not there, in that case there will be a tension in this particular string. And obviously this tension will be having the magnitude same as weight. It was our case under consideration, and the block will remain stationary. As I apply the force, it will change the position. Now there could be some other tension which is acting onto it. Weight remains downward, and there is a force which we have applied, F. And these three forces are in such a manner that the body is not moving. Now when we talk of the plane surface, any plane surface, here even if the body is hung and if I apply the force, it shifts. Still it is a movement in one plane. It is this plane which is under consideration. So we are talking about a plane movement, and if it is a two-dimensional object, obviously the movement also can be considered along the two directions x and y. That is what we call it as a 2D. And if the body is remaining stationary at a particular point, it straight away means that it is not going to move along x-axis, either positive or negative, or along y-axis. In other words, if we just consider all the forces which are acting along horizontal direction, they must be balanced, so that net displacement in the horizontal direction will be 0. Similarly, net displacement in the vertical direction is also 0, so all the forces which are acting in the vertical direction, even their sum should come out to be 0, and the body will be in equilibrium. Now here we have got these forces in the inclined manner. Now the question is, if you are talking about something like force in the horizontal direction and force in the vertical direction, what is that all about? We can't see any horizontal force over here. We have got one vertical force, no doubt, but there are no horizontal forces, and then how are we going to solve this problem? Here another factor comes into picture, which we will be referring to as resolving the forces. And here we will have to understand some basic concept which is related to vectors. Now suppose on a plane, if you are to move from one point to another, you can have a movement in this manner. So you have started from this point and reached this point, but this movement can also be achieved by moving horizontally and then by moving vertically. If this particular principle is understood, that is whether you take a path from A to B and then from B to C, then it is as good as going from A to C. That means in vector notation form, I can write it as AC bar is nothing but AB bar plus BC bar. If this concept is understood, I suppose it should be easier for us to explain the remaining features, because then when we talk of a force, it is something like this, which can be resolved along horizontal direction or in the vertical direction. Or in mathematics you must have studied something like polar coordinates. That is, a point is defined in terms of r and theta. And we often ask you to find out what is the x coordinate of that point and what is y coordinate, and you are aware that x coordinate comes out to be r cos theta and y coordinate is r sin theta. And if the same principle is applied, we can go for actually the same point from origin if the coordinates are x and y. In vector form, this particular vector OP bar can be written as xi plus yz. And what is I? I is the unit vector along positive x direction. Z is unit vector along positive y direction. Generally they are denoted by cap to indicate the unit vector. That can be omitted. And so OP bar comes out to be xi plus yz. But what is this xi plus yz? It is actually r cos theta I plus r sin theta z. And you are also knowing the fact that I components cannot be added to z components. This itself remains the answer. There is no value with I and z. These are the direction specifiers. So it is r cos theta along positive x and r sin theta along positive y, and then we will reach the point. If this concept of vectors is true or this concept is true, or we can say that if the force is applied to the body or you have got some block which is resting on some plane, and if you are to move this particular block to some position like this, then I might suggest that you apply a force in this manner and keep on shifting this so that it will occupy a position over here. Is it understood? So that the block moves to this position, and then to get it to this position I will say that apply a force in this manner. Effectively what you have done, you have applied a force, say F1, and then you have applied a force, say F2. This is when we want to move it at right angles. But it is very well possible that I might apply some force which will straight away push the object to this position, and that direction is going to be this direction. In whatever way you try to assume it, you will always find that a force can be divided into some components, some parts, which we call it as the resolving of the forces, and generally it is the horizontal and vertical direction that will come into picture, and that horizontal direction, or which we call it as the x direction, because we are talking about the plane motion only, 2 dimensions, and so horizontal and vertical are the two words, and if a force F bar is making some angle theta, then it can be resolved into two parts, one which is horizontal portion, which is F cos theta, and other which is vertical, F sin theta. This is called as resolving the forces. So resolve the forces along x direction and y direction. So far so good. Suppose we have a force which is acting in this direction, say F2, making an angle of theta 2. Then this value will come out to be F2 cos theta, F2 sin theta 2, and this will come out to be F2 cos theta 2. Now what happens is, to this force, say initial was F1, to this force F1 if I want to add this F2, then there will be a problem, because it is not F1 cos theta 1 plus F2 cos theta 2, because they are having opposite directions. So I will have to assume one of the direction to be positive, and so I treat this as positive because it is along positive x direction, and this is along negative x direction, so should be treated as negative. Now every time thinking in this manner could be slightly troublesome, because then you will have to actually have that picture like this is F1 bar making an angle of theta 1, this is F2 bar making an angle of theta 2, and then you actually find out the components and then move so that negative x positive y, this is positive x positive y, like that you will have to imagine. Now of course, if I say that these two forces are acting on the body, what will be the effect on this body? Then you might say that it will depend on values. Why? Because there is one force which is F1 cos theta 1 which is pulling the body to the right, whereas there is another force F2 cos theta 2 which is pulling the body towards the left, and there could be some resultant of these two, unless they turn out to be of the same value. And then when we talk about the addition in the vertical direction, that is along y, then remember both of them are upward. I am quite sure that this body has to move in the upward direction. I cannot be sure of whether the body will be moving towards left or towards right, because that will totally depend on the comparison of these two values. Which one is greater? If F1 cos theta 1 is greater, it will be moving in the first quadrant. If F2 cos theta 2 is greater, then it will be moving in the second quadrant somewhere. But I am quite sure that the object, this particular body, has to move in the first quadrant or second quadrant. I am quite sure that it is not going to move to the third or fourth quadrant. And if this movement is to be stopped, then I will have to apply one more force, and that force need not be every time vertical, because if I just apply a vertical force, say F3, then what will happen? And I am making a statement that this F3 has got the same magnitude as that of F2 sin theta 2 and F1 sin theta 1, the addition of the two. Then obviously you will say that there is no net force in the vertical direction. But then what happened to these two? F3 is not going to produce any component along horizontal direction, and it will still depend on these two. And unless we are given that F2 cos theta 2 is equal to F1 cos theta 1, we cannot say that the third force which will bring the body in equilibrium should be vertical. I again repeat the statement that unless we know the magnitudes of F1 cos theta 1 and F2 cos theta 2, that they are equal, we cannot apply a vertical force to bring the body to its equilibrium position. But if these two are given to be equal, then definitely F3 will be equal to F2 sin theta 2 plus F1 sin theta 1. It is one direction which is considered at a time. For a body to be in equilibrium, the net external force along x direction should turn out to be 0. There need not be only a single force, two forces, 3 forces, 10 forces acting on it, but their addition should turn out to be effectively 0, and that addition is 0 because the forces are associated with directions and opposite direction is treated as a negative force. So there is a concept of positive force as well as negative force. Conventionally, towards right is the force which is positive, towards left it is negative, upward is positive, downward is negative, one of the very fundamental principle. And we will be having the cos components, sin components. It depends as how the angle is given to you. Now if I have F3 which is making some angle theta 3 with vertical, then of course the horizontal component, because then I will have to move along x, along y in the downward direction and along x towards left. So it is going to have this much value as negative in the vertical direction and this much value as negative in the horizontal direction. Now if this angle is theta 3, then this component will come out to be F3 cos theta 3 and this will turn out to be F3 sin theta 3. Observe that in the previous two cases I had the horizontal component as F1 cos and F2 cos, and here I have the horizontal component as F3 sin. Here I was having the vertical component as sin and sin, here I have vertical component as cos. It all depends as where the angle has been shown. Whether it is angle with x-axis or y-axis, that will determine whether it is cos or sin, and that too whether it is positive or negative will actually depend on the direction. So there are so many considerations which will come into picture. Now this can be in equilibrium. It will depend on what are the values of F1, F2, F3 and theta 1, theta 2, theta 3. They cannot be 0 only at a particular value. There could be several combinations which are possible. And we are going to deal with only a concept that the external forces in the horizontal direction should be balanced, external forces in the vertical direction should be balanced. After considering the basic principles which will go with the equilibrium of the object, let us consider a few problems and see the procedure for solving those problems. Say there is a point which is acted upon by the external forces F1, F2 and some other force F3. So there is some hook which we can show over here, to which these forces are applied. We are also given the angles made by each of these forces. The angles are given in quite a different way. So these are the three angles which are given to us, and even the magnitudes are given. Say force F1 is having a magnitude of 100 newtons, F2 is having a magnitude of 120 newtons, whereas F3 is having a magnitude of 85 newtons. The angles are 35 degrees, 20 degrees with vertical, and this angle is given to us as 40 degrees. They are acting at point P, we say. And the problem statement says that find the resultant force. Find the resultant force acting at P. Now to find this particular force, we are required to find out the net force in the horizontal direction and net force in the vertical direction. Now if we recall our earlier procedure, then even that procedure can be used to solve the problem, but let us solve it through the components. So using the components, and when we say that we are going to use the components, for every force we are required to find out the horizontal component and even the direction of it. So horizontal and vertical. So every force should be divided into the magnitude in the horizontal direction and its sign. Similarly, vertical force, its magnitude and sign. Sign means actually direction. For horizontal I am going to say towards right is positive, and for vertical it is upward positive. Now force F1. If you consider force F1, I am drawing the small figure also over here as a supporting one. So this angle is 35 degrees and the forces will be resolved like this. This was force F1. So obviously magnitude, horizontal magnitude is going to be 100 cos 35 and it is towards right, so positive. And vertical is 100 sin 35 and upward, so positive. Now look at force F2. F2 force is making 20 degrees with vertical, so we can draw in the table force F2 drawn in the same manner, F2, and you will find that it is in this manner and this is the angle 20 degrees. So horizontal component will be, magnitude is 120 and horizontal, this is theta, so opposite side it is going to be sine of 20 degrees and towards left, so negative. Similarly, the vertical component, it is adjacent side, so it is 120 cos 20 upward positive. And then we consider force F3, which is making angle with the horizontal. This is the angle. So for force F3, it is going to be 80 cos 45 or 40. It is adjacent side, so cos, and towards left, so negative. Whereas vertical component is opposite side, so F3 sin 40 and upward, so positive. So I have found out the components of each one of them, and therefore resultant in the horizontal direction is going to be, with signs I am required to add them, so it is plus 100 cos 35 minus 120 sin 20 and minus 80 cos 40. You will get the horizontal force. And R vertical will come out to be 100, it is of course plus 100 sin 35 plus 120 cos 20 plus F3 was 80, so it is 80 sin 40, and so we get the net resultant. Once we get the net resultant force, we know that the net vertical force is positive, of course. Now the question remains as what is R horizontal? R horizontal comes out to be, is it positive or negative? So R horizontal comes out to be negative, and so we can say that the horizontal is like this and vertical is like this. So we can find out the resultant of these two, which is R. And even by the Pythagoras we can find out the net resultant force is nothing but under root of R horizontal square plus R vertical square. So net horizontal force can be found out. And if you consider this angle as theta, then you will find that R horizontal upon R vertical comes out to be tan theta. So tan theta is equal to R horizontal upon R vertical. Again, the common mistake that students will commit over here is to consider this horizontal with sine, and in that case this tan theta will go wrong. Whenever you consider this ratio should be taken in the mod form, because we have shown the angle in this case. And then the final answer will be shown in the same manner, that is, you are showing the resultant force, write the magnitude so many newtons, and you are required to show the angle as so and so. This is how the answer should be written in the final exam. This is one way of solving the problem, which is totally analytical. We are making use of sine component, cos component, and even the directions we are finding on our own and assigning the signs. Another way of solving the same problem is the tabular technique. Once we are through this particular problem, let us proceed to another way of solving the problem, which is similar to the vector approach, and some responsibilities we are now throwing it to the use of the calculators and all. Here I am going to say that first of all redraw the figure in such a way that we will be showing the angles made by each of these forces with positive x direction. So it was 100 newtons force F1 making 35 degrees, so there is no change. Show angle made by each force with positive x direction, and so when you go with the second force F2 having magnitude as 120 newtons, angle made by it with horizontal will be 90 plus 20, that is 110 degrees, whereas the third force F3 whose magnitude is 80 newtons, its angle will turn out to be 180 minus 40. So this angle in all will come out to be 140 degrees. So we say that show angle made by each force with positive x direction, and of course in anti-clockwise. In anti-clockwise manner you are required to measure the angle. If you do this, then our job will be very simple, because then we can make a table of force, angle horizontal component, that is Fx, vertical component Fy. And remember, if this is force F, angle theta, then Fx will be always F cos theta and Fy will be always F sin theta, and you don't have to bother at all about the directions. Here we don't have to think about, not to think about directions. Angle will take care. Angle will take care as whether it is positive or negative. So let us complete the table. This is 100 newtons, angle is 35 degrees. 120 newtons, angle is 110 degrees. And 80 newtons force, angle is 140 degrees. And accordingly you find out cos theta, F into cos of this angle, F into cos of this angle, F into cos. You get these three terms over here, add them. You will get the sum of these three entities. Then 100 into sin 35, 120 into sin 110, 80 into sin 140. Write those three values and then find the addition of them. This addition I will be calling it as sigma Fx, and this addition is sigma Fy. Once we get these two additions, then resultant is nothing but under root of sigma Fx bracket square plus sigma Fy bracket square. So you can get the resultant force and angle made by it. So you can find out tan theta, which is going to be mod of sigma Fy upon sigma Fx. So you will get some value. I will call it this as theta 1. So you will get value of theta 1. Now this theta 1 should be shown properly. Now there are cases like what is the sine of sigma Fx and what is sine of sigma Fy and what will be the actual angle. This table should be remembered. If both are positive, this angle is theta 1. If sigma Fx is positive and sigma Fy is negative, this will be minus theta 1. If you have sigma Fx as negative and sigma Fy as positive, this angle will come out to be pi minus theta 1. And if you have both as negative, then the angle will turn out to be 180 plus theta 1. And so even theta 1 can be found out, theta can be found out correctly. A vector technique by which we can obtain the solution. So see the problem that was given to us. We were given angles with different axes. First of all, we had changed those to angles with positive x direction, and then we made the table of force, angle, Fx and Fy. It was horizontal force, which is always F cos, vertical force, which is always F sin. Take the addition, square them, add them and take the square root, you will get the resultant force. To find the angle, it is sigma Fy upon sigma Fx mod, and then find out theta 1. And to find out the correct angle, this is the table, and so you will get the corrected angle also, and the solution will exactly match with our previous technique. And the third one that we want to see is a graphical technique. Third one is the graphical technique by which again the same problem can be solved. For that, some more tolerance is available for the solution, because it will all depend on with what scale you are going to draw that diagram. Of course, graphical is not the expected solution unless it is explicitly mentioned in the question. We start with a point. I am using the triangle law of addition. So triangle law of addition of forces. You draw a line at 35 degrees and measure, so angle of 35 degrees, and measure distance which is proportionate to 100. Now suppose I am using the scale as 1 centimeter is equal to 10 newtons, then you are required to draw a line of 10 centimeters. So I am showing here only the centimeters. Then at this point, so this was force F1 that has been shown. At this point, at the tip of it, draw again x and y directions, and we know that angle made by F2 with vertical is 20 degrees. So at the tip of F1 that we have drawn, we are required to have the angle as 120, angle as 20 degrees, and you will be measuring as much as 12 centimeters over here, because the force was 120 newtons. And once this has been found out, then we will proceed further. Again at the tip we will draw horizontal and vertical line, and a line at 40 degrees. Measure 8 centimeters onto it. This was force F3. So this is just the triangle, and effectively we have moved from this point to this point over here. This is the resultant force, R bar, which is the triangle law of addition of forces. You are required to measure this distance. Suppose it comes out to be x centimeters, then the resultant force will be x into 10 newtons. That was our scale. And of course angle made by this force with vertical can be very well measured. Or you can measure angle made by this resultant with horizontal, that will be the required theta. So even a graphical solution to this particular problem is possible using the triangle law, or you can go for the parallelogram law of addition of forces. So let us even see that. In case of parallelogram law, addition of the two forces, here where the tip of first force was there, we had the start of the second. So one vector is drawn. Here only we are starting with the second vector. From that point we are starting with the third vector. So it was like a cycle that we were continuing. Now in case of parallelogram law, we will be having all the forces starting at the same point. And so here is the first force which is shown, of course to the scale. So this is again 10 centimeters that is drawn at an angle of 35 degrees, and then you have at 20 degrees another distance 12 centimeters. Then you are required to draw a line parallel to this from here and parallel to this through this, and if you join these two, then this will come out to be the addition of F1 and F2. So this will be F1 plus F2. So first two forces are drawn, parallelogram is completed, and then diagonal through the same point will give me the resultant. And then we have force F3, and then we have this force F3, which is making 40 degrees. Now at this line, so with the resultant, you are required to complete the parallelogram. And then whatever is the resultant, that is the diagonal that you get, will be the actual resultant. And then you can measure angle made by this R with positive x. Again this R coming out to be x centimeters, x into 10 will be the resultant force in newtons, and angle can be directly measured. So there are 3 or 4 different ways of solving the problem. Excluding graphical way, we have 2 techniques. One is analytical and other is the vector approach. Let us take down 1 or 2 problems more. Which are again to find the resultant. So the second problem, we are given the forces F1 of 45 newtons making an angle of 40 degrees. We are given F2 of 55 degrees, 55 newtons making an angle with vertical as 25 degrees. We also have a very small force of 10 kilonewton, 10 newtons, F3, which makes an angle of 35 degrees with vertical. And we have a force of 60 newtons making an angle of 45 degrees. And the question is, find resultant force. Procedure remains the same. Equations can be written in a faster manner, like sigma fx. If I am to continue with the same figure, will come out to be 45 cos 40 degrees positive minus 60 cos 45 negative, towards left is the component, then minus 10 sin 35 degrees and plus 55 sin of 25 degrees, and sigma fy will come out to be 45 sin 40 degrees plus 60 sin 45 degrees minus 10 cos 35 degrees and minus 55 cos 25 degrees. One approach for solving the problem. Second approach, it is table F1, F2, F3, F4, that is forces are 45, 60, 10 and 55, and of course angles, first is 40 degrees. Now you can find that this angle, if I am to measure, it is 180 minus 45, so 135 degrees. This angle with positive x, this is the angle that we want to find. It will be 270 minus 35, so it will be 235. And then this angle is 270 plus 25, so 295. And then these are all costs, these are all sine. Second way of solving the problem. Calculations, I am leaving it to you, because if you are, after this point, if you cannot calculate the things correctly, then it cannot be simply proceeded further. Consider one more problem. Third, we are given force F1, we are given F2, we are given F3, and we are also given F4. Magnitudes are 150 newtons, 100 newtons, 120 newtons and 75 newtons. And the slopes are, this is 2:5, this is 1:3, this is 1:1.2. Now observe that in this case, instead of giving the angles directly, what he has given, is the slope of each line, and so it will depend on how you find out the angle and which angle is found out. So for this, if I consider this as theta 1, then I can say that tan theta 1 is equal to 5 by 2, and so theta 1 can be calculated, and that theta 1 is this angle. Similarly, if you consider this as theta 2, then you will have tan theta 2 as opposite upon adjacent 1 by 3. You will get theta 2, that theta 2 will be this angle. And here, if this is theta 3, if some naming problem is there, then call this as theta 3. Third force, call this as theta 4. So tan theta 4 opposite upon adjacent is 1 upon 1.2. So you can find out theta 4. And where is this theta 4? With horizontal? With horizontal. So this will be theta. And then the problem reduces to the previous one. Of course, angle made by F2 with horizontal is 90 degrees. Or F2 does not have horizontal component. You can solve it by either technique. One of the straightforward type of problems.